In this session, we will see what is flow monitoring, what is flexible NetFlow, why do we need flexible NetFlow components, how to configure them and verify them. A flow monitoring tool is a tool that provides network traffic visibility or monitoring way better than we can achieve with SNMP, where traffic information is collected on a per flow basis. Compare the type of information that we can gather with SNMP with the type of information that we can gather with flow monitoring. A flow is a unidirectional sequence of packets with common parameters. Let's place an example. Let's say that the common parameters in order to identify one flow are going to be source IP address, destination IP address, protocol number, and port numbers. By that rule, packets 1 and 3 in this example will belong to one flow because they share the same parameters. In this example, packet number 2 will belong to a different flow. Flow monitoring performs two basic actions: matching packets into flows and then collects data from packets and storing it in flows. So the set of parameters that identify flows are known as matches or keys. In this example, our matches are the source IP address, destination IP address, protocol number, source ports, and destination port. After classifying packets into flows, data gathering takes place. Specific packet field values are gathered. These fields are known as collects, non-keys, or fields of interest. In this case, we are going to place an example. We are going to collect packet size count and packet number count. So for flow number 1, we are going to gather the packet size, so it becomes this number, and packet count, it becomes this number. The same applies for flow number 2. By default, all key values are also collect values. So in this example, flow 1 is also going to collect the source IP address, the destination IP address, the protocol number, and the port numbers. The same applies for flow number 2. Just a note here, a record is made of matches and collects. Remember that matches are also known as keys and collects are also known as non-keys or fields of interest. In the example that we have been talking about, the record will look like this. There are two types of records, predefined and custom. Predefined records come out of the box and are ready to use, whereas user-defined records or custom provide more freedom but take some effort in order to get designed appropriately. Flexible NetFlow supports both predefined records and custom records. Flow monitoring tools can perform traffic analysis in two ways. With full traffic analysis, all packets going through an interface get analyzed. This provides accuracy. With sampling analysis, we are going to take samples every once in a while, and then we are going to analyze packets within these samples only. This way, we keep device performance at the cost of losing accuracy. By default, Flexible NetFlow performs full traffic analysis, but it can also do sampling analysis optionally. Flow monitoring tools have two ways to operate: a stateful operation where the data is consolidated inside a cache first, and then after some time we are going to move data from the cache to the collector server. And we have also a stateless operation where the flow monitoring tool is going to send flow data to the collector as soon as possible. Flexible NetFlow works with a stateful operation. In order to move packets from remote devices to flow servers, we must choose a format and a destination UDP port number. Flow servers must be able to understand the flow data format and must be waiting packets on the appropriate port number. The selection depends on the flow monitoring tool. For instance, for Cisco, we can use these options. For SFLOW, we can use this option. For Juniper, we can use this option. And for Huawei, we can use this option. Flexible NetFlow can only use version 5, 9, and IPFix. There are several flow monitoring tools out there. I have put together a few of them in this chart where we can observe per product the vendor name, the product name, whether the product is a standard or proprietary, whether it is a stateful or a stateless, what type of keys can we use to classify flows, if it supports full traffic analysis, if it supports sampling analysis, the data format it supports, and the destination port numbers it uses. What is Flexible NetFlow then? It is a Cisco proprietary next-generation flow monitoring tool that evolved from a previous product known just as NetFlow. The new features include custom records, sampling, traffic analysis. It supports the packet inspection to classify flows per application. It works with MVAR2, supports the more recent format known as IPFix, also known as NetFlow 10. So why do we need flexible NetFlow? We can use it for accounting, for instance, to perform customer billing. We can use it as a troubleshooting tool to address congestion or application slowness incidents. We can use it as well for forensic analysis. We can use it for security analysis because we can track threats to the networks, for instance, to detect DDoS attacks. We can use it for real-time network monitoring and network planning, for instance, to perform capacity planning, identifying optimal quality of service parameters, or traffic engineering. These are the flexible NetFlow components. We have flow records, we have flow exporters. Then we put all of these together inside a flow monitor, and we can configure optionally a flow sampler. First of all, we have the flow record, which is a combination of matches and collects. It defines the cache entries, how to classify packets into flows with matches or keys, and what information are we going to gather with collects, also known as non-keys, also known as fields of interest. Remember that we have two types of records. Option 1, using predefined records that are easier to use than custom records. Option 2 is creating custom record, which is difficult to design. The NetFlow original predefined record is not supported in Catalyst 9000. Next component, exporters. We may have several exporters. Exporters answer the question, to what IP address are we going to send flow packets, and what export protocol are we going to use? Within the exporter, we can configure several settings for the packets that we are going to send to the collector, for instance, the DSCCP, UDP port, MTU, TTL, or source IP address using the source interface. Notice that we cannot use the management port as source interface. The next component is the flow monitor. The flow monitor contains a flow record and at least one flow exporter. After configuring a flow monitor, we are going to apply it to a network interface. After applying it, we are going to start classifying packets that are going through this interface into flows according to the flow record. This information is going to be stored inside a NetFlow cache. Then the flow exporter is going to be in charge of taking this NetFlow cache data, and it is going to send it over the network to a collector server. The final component is the flow sampler. This is an optional component that will reduce the load or processing overload on the device running flexible NetFlow by limiting the number of packets selected for analysis. In fact, it will exchange NetFlow accuracy for device performance. In order to create a custom flow record, we will use this command, flow record, and the name of the custom flow record. We will need to provide the keys and collects that will create this record. Be aware that creating these custom flow records may become complex. You will need to go through a design phase before start configuring one of these. Now, in order to configure an exporter, we need to provide the IP address of the server, optionally the BRF for this IP address, and we need to configure the formats of the packets. We can choose from version 5, version 9, or IPFix. Optionally, we can configure the source interface and the UDP port number. Next up, flow monitors. In order to configure a flow monitor, we need at least one record. We can go for the NetFlow original record. This is not available in Catalyst 9000. We can go for other predefined NetFlow records, or we can use a custom record. We need at least one exporter. We can have more than one. We may configure the cache, and in order to apply the monitor to an interface, we will use the command ipflow monitor, the name of the monitor, and the direction. Optionally, we can change the operation mode of NetFlow into sampling. With the command sampler and the sampler name, we can configure the sampling method. After configuring the sampler, when configuring the monitor, we can supply the sampler name in the same command. In order to review the verification commands for flexible NetFlow, we are going to do a lab. We are going to connect this Catalyst 9000 to the local area network. We have several devices here that are going to be sending traffic, a lot of broadcasts and multicasts into this interface. So we are going to create the easiest record, the easiest custom record, where we are going to match only the source IP address, and we are going to collect the packet size, and then we are going to create an exporter that is going to send packets to this destination, and we are going to use IPFix as the format. And finally, we are going to create a monitor that is going to include this record and this exporter, and we are going to apply this monitor to this interface. This is how we start the lab. We have this configuration in the interface. We don't have exporters, we don't have monitors, we don't have custom records. So let's start configuring it. Let's configure a custom record first. So we are going to do flow record, my record. And the key will be an IPv4 source address. And we are going to collect a particular counter that will be packets. And let's capture also the bytes as well. So if we should show flow record, my record, this is how it looks like. We are going to match, this is the key, and these are my two non-keys. Let's configure the exporter now. So it will be flow exporter, my exporter. Now we are going to establish the IP address. In this case, it will be this one. We can establish a VRF. In this case, we are using the global routing table. So we need to also establish this port protocol. Notice that for Catalyst 9000, we only have NetFlow 9 and IPFix. So let's choose this one. So if we issue show flow exporter, my exporter, it will look like this. Let's configure the monitor now. So let's issue flow monitor, my monitor. We need to set up record. Notice that in case we only have the custom record that we already created and some traditional predefined record. So let's choose my record here, and the exporter will be my exporter. Everything else we are going to leave it as default. So if we issue show flow monitor, it looks like this. Now let's apply this monitor to an interface. We are going to choose gigabit 103 IPFlow monitor, my monitor in the input direction, and let's set it up in the output direction as well. Okay. Now we can issue, for instance, show flow interface gigabit 103. We have this monitor in the input and output direction. Let's review how the cache is going on. So we could issue show flow monitor, my monitor, cache. Let's examine what does the cache have. We can see that these are the IP addresses that we have found. This is the easiest record type because we are consolidating flows based only on source IP address. We don't have any more keys, only the source IP address. So every single packet that shares the source IP address will be consolidating here. We are summarizing the amount of bytes that have been transmitted using this source IP address, the amount of packets that have been transmitted using this source IP address, and so on. We can order this. For instance, we can sort it based on the highest counter, for instance, bytes long. So we can show this to the customer or to the end user if we wanted to. We don't really need Flow server. At this point, we can gather statistics from the device itself. So we can sort it also by packet count. That will be it.